So welcome to everybody that has dialed in already, and I'm sure some more people will join later. So this is, I think it's the 10th, but it may also be the 9th, I must say, webinar of the MAIA project. As most of you know, MAIA is a Horizon 2020 project funded by the European Union with the aim of supporting and promoting the testing and application of SEEA ecosystem accounting, the system of environmental economic ecosystem accounting in the EU, with 11 countries participating. And yeah, partly in response to COVID, we had to move some of our activities, of course, online. And one of the ways we decided to do that was to have a number of online webinars on specific technical elements. And this webinar is a bit particular, I realized this morning, because for two reasons. First of all, it is not dealing with a specific account, but with a set of ecosystem services. All the other webinars were about an account, a condition account, an extend account, except the introduction webinar, of course. But this one is focusing on hydrological services, water-related services. And of course, there's the water accounting, which used to be in the SEEA EA ecosystem accounting framework, but in the experimental ecosystem accounting framework, there was also water accounts, but in the ecosystem accounting, so the updated version, there is no longer a water account. And the reason for that is that water accounting is, of course, covered in the SEEA central framework. But of course, all the hydrological ecosystem services are still very much part of the SEEA ecosystem accounting approach. So this webinar is peculiar because, well, the focus is not so much on an account, but on a set of services in that context. And the second reason is that we've got more speakers from outside the MAIA project from inside. So that is interesting. So, and it's really much appreciated, obviously, that Michael Varen and Sarah Vallecillo and Neville Crossman have been willing to speak in this webinar. So thank you very much, right, for making yourself available, and also for dealing with the time difference. Two speakers are from Australia. And of course, Toyin, also many thanks to you for setting up and organizing the webinar. I'm sure it will be really interesting and important because, frankly speaking, I think those set of hydrological services, they are really among the most challenging elements that we have to do. On the one hand, I think hydrological services are really crucial to set up the ecosystem accounts because they're really important ecosystem services, and I think a big part of the economic value many types of ecosystem service is in those hydrological ecosystem services. And on the other hand, if you want to do this properly, you should do it really with a fine resolution, both in time and in space. And at the same time, you need to do that for large areas. And it's really challenging to do so. So I really look forward to this webinar and to learning some new insights on how that best can be done. Thanks again to the speakers. Thanks everybody for joining us for this webinar. And I think, Michael, the floor is yours now. So I really look forward to your presentation.
I'm going to start off by saying that like most ecosystem accounting or any sort of accounting, it involves a lot of people. And over many years, I've been very fortunate to work with a lot of very good people from both within Australia and across the world. So I'd just like to acknowledge some of the key contributors here, and I'll do that again at the end because it really is a team effort. I'm going to go through it. I mean, Lars mentioned that this is a theme-based, focusing on the water-based ecosystem services, and that the water is covered in different parts of the SEEA. And I just wanted to spend a little bit of time just on that, how it all fits together, so that it's all part of a jigsaw puzzle. So how it fits into the SEEA, into the central framework, how it fits into ecosystem accounting. I'm going to go through some case studies just to show how we can account for different things, different services in different ways, and also just some of how we account for intermediate ecosystem services and final ecosystem services, which is a very important distinction in ecosystem accounting, and also has implications for how it's done in the central framework and links to the national accounts. We're going to look at something from Botswana, some water and wildlife. So thank you to my colleagues Pule and Dimfo for assisting me with this. And then in Australia, some water supply, catchment management, and how some ecosystem accounting there help us assess some trade-offs. And then we get to just how is it that we're going to use that? And this isn't just the ecosystem services, but accounting more generally. So we'll just spend a little bit of time on that. The first thing is, it is part of a system. We have the national accounts, it's monetary, mostly production, and we have what's called an asset boundary. And there the assets have to be capable of being used and owned for economic production. So that's one clear boundary in the SNA. In the SEEA Central Framework, we don't have that boundary. Things just have to exist. So if you're not using your waterfall, you're just looking at it, we include that in the SEEA Central Framework, although that wouldn't be included in the national accounts, although the cafe selling the drinks to the people who are looking at the waterfall would be included in the national accounts. We have the ecosystem accounts, which have gone even further, and I'm very pleased to say, thanks to the hard work of Lars and many others, we can take the word experimental out of ecosystem. We have agreed on how we should do it, at least in physical terms. And this is very important. We now have a system, it's agreed, we can get on with it, we can do it, and we can compare things between countries and between projects as well. We then come to this, there's still more material. There's a lot going on in water. Water accounting, it started with the SEEA Water in 2007. And I'd like to say the original and best SEEA, having been closely involved with its development. But it has been around. It's one of the longest. Water is essential. You can't have life without water, and is indeed one of the most, or if not the most, compiled type of account in the world. Lots of things are there to support the implementation. And we're going to get to these key concepts of the environmental accounting. And this is, the focus is often very much on the services. We need to remember that the services come from the stocks. They also come from other inputs. So we have stocks and flows, this physical and the monetary, and often we get tied up in the monetary, but at least if we can agree on the physical and how we're going to measure it or even model it, we're going to hear some more about that. That's also important. It also gets here to these benefits and beneficiaries. And there are some key benefits and there are some key beneficiaries, and not all of the benefits occur within the production boundary of the system of national accounts. And here the beneficiaries are different groups of people. So you can have a farmer that benefits by irrigating his crops, or I benefit by drinking my glass of water. So,
Michael, can I just interrupt you for a while? We see both your slide and the next slide. If you turn on
okay,
in a real full screen, it would be probably better.
Is this better? Does that work?
Yes, definitely.
Okay. Oh, I'm sorry. You can see my notes then, which is good. There's no secrets. That's good. Thank you. But why do we use it? And I think the key for using accounting, I mean, one, if you don't measure it, you can't manage it. I mean, that's a bit of a, it's a truism, but it really is something that gets there. But I think one of the keys is you're converting information into a form that agencies at the center of government understand it. It links directly into the SNA, which informs major decisions. So we can get it into a language which is understood by central banks, ministries of finance, and central planning agencies. And that is key. It puts it into a set of accounts, it makes the values explicit, and it means you can make trade-offs explicitly as well. If you're doing something, you at least know what happened, and if you use it with some other information, you can try to test some of what accounting can do. And in this, accounts get much more beyond monitoring. Accounting has traditionally been seen as a way that you monitor things, but it really can do more than that. And I will return to that theme in a moment, towards the end of the presentation. Once again, stocks and flows, everyone I think will have seen some sort of diagram like this. We have the inland water resource system, water flowing around within it, and then water going into the economic system. The SEEA water only covers part of the flows, and many of the ecosystem services that we're going to be talking about aren't included in this diagram or don't come from some of the things represented in this diagram. We certainly have the inland water resources, the surface water, groundwater and soil water, but we don't have things like the rivers themselves, the vegetation on the rivers, the vegetation in the catchments. That doesn't show up in this system. That is what is different about it. Also, the flows going into the economy are more than just the simple abstraction of water and the return of water. It is much more than that. So the SEEA water is a very good start, but it doesn't cover everything. It's a very good start. I mentioned that it's one of the most compiled water accounts. Here's just an example. It's virtually the A to Z. Oh, I'm sorry, I got the USA and Zambia out of order, but it really is the A to Z of countries that are doing this. And many more, or some of these countries are also doing ecosystem accounting as well. All of this to say, there's a lot of work going on. Different countries have done it in different ways. Some countries have a long time series like Australia and the Netherlands. Others have some shorter time series, but for Australia, which I know reasonably well, has data going back to 1995 right through to the present. The SEEA water is very big. It's not just supply and use, it's not just an asset account, it's many things. We can have emissions to water, we've got hybrid accounts, we've got monetary accounts, we have the accounts for the government businesses or any business which provides water, wastewater treatment. There are at least 12, well, there's 12 accounts in the SEEA water plus 12 supplementary tables. We then go to try to account for other things as well. The main point I'm trying to get across here, there are many, many accounts. And if we start to get to the assets and ecosystem assets, there are many ecosystem assets that we can categorize, and we have to plot these spatially. So we're not doing it for a country or a province. We're trying to get it down at a much finer spatial resolution, often. Lots of tables. The Water Accounts Australia, it has about 25 tables. Most people don't like tables. They won't read them. Us, or many of us, will be data scientists and we love tables and we can plug them into our models. We can do that. But to communicate it to other people, we really do need to use more than just tables. I used to be a fan of just let the data speak for itself, don't commentate. I've very much changed my mind. You have to commentate on the data because not a lot of people understand it. So we have to interpret it. This is an uncomfortable space for some of the national statistics officers to be in. They don't like to explain things or to provide comment on things. They are often very good at doing nice diagrams though. And here, here we're telling a story. You can't quite see it, but down here, this is agricultural water use, so it's about 50% of total water use in Australia, and they pay about 8% of the revenue. Households pay about 50% of the revenue, but only use about 10% of the water. That tells a story, and you can interpret that. There's other things that you can say. One, the difference in water quality is obvious. When it goes to households, it needs to be drinking water, so there are other costs. But you need to explain that to people. You can't just let the data speak for itself. You have to do a bit more interpretation. The other thing is the indicators and the time series. The accounts get better the longer you put them together. Your data gets better, the understanding gets better, and you identify and fill the gaps. So this is just a bit more about the water accounting in general. But then we get to the ecosystem accounting, and there is just a massive work going on in this, particularly for ecosystem services. I find it impossible to keep up. There is just so much going on all around the world. Certainly Europe has been some of the leaders, Lars Hein and his team, but Alessandro Lanotte and other people in Europe really are putting out a lot of material. Ken Bagstead and his team in the USA. If I keep talking, I'm inevitably going to leave someone out, so apologies, because I know there is just so much going on. Every week something comes out that I should read, but it's impossible. I've just found it simply impossible to keep up. But all of this to say, there is a real push for this going on. Whoops. But one of the key issues is it's all being done still slightly differently in different places, if not very differently in different places, which is where the SEEA can help just to provide that standardization so that we can begin to compare between studies and between different parts of the world. So the ecosystem accounting, I keep coming back. A lot of this in the ecosystem accounting has focused on the services. We will get there, and I think that is really, one of the key things. But the services come from assets, and I think that's very important to remember. I think we all, familiar with a small lake with some trees around it, perhaps a river in the Amazon. But here we have my own jurisdiction, the Australian Capital Territory. So this is the vegetation map. This is the water supply infrastructure that's in the territory. So we have 4 dams supplying 2 cities from 2 river catchments. We can account for all of that. We're in the process of preparing the accounts, full ecosystem accounts for the Australian Capital Territory. But we have the lakes, rivers and dams, the vegetation and the soil. All that. Okay, I'm just keeping an eye on time. There are a lot of water-related ecosystem services. I'm not going to go through them all. SEEA is the classification nominated in the SEEA. Still many people are using things outside of that classification. But many things are there. This is just what I wanted to show briefly. I don't really want to go into it much detail, but we have some intermediate use of ecosystem services. So final ecosystem services are when people, just getting rid of that, hopefully, go to people. So to economic units or people. So people drink water. So if they extract the water from a dam, that's a final ecosystem service. But before the water gets into that dam, it's probably runoff out of a forest where there's a water provisioning service and a water filtration service to do that. So this is all looking at how we can account for the water getting to a household. We can then split the ecosystem, so we can have a forest providing water to a reservoir. It's then extracted by the water supply industry, and then it goes from a water provisioning service to a water product, which very confusingly is called natural water, and then it goes to the households. You can then start to combine them in this. All of this, there are some accounting options that are open, and you can do some simple accounting or you can do some complicated accounting. I think it's often useful to split the ecosystems and the 2 economic units out. It all depends on the objectives of your study. Okay. Just going to look at a case study from Botswana in Southern Africa, a very dry country. This is a study published before SEEA ecosystems and before I had a good knowledge of ecosystem accounting, which is still evolving. And this gets to the water being used by wildlife, which is not mentioned in the SEEA. What we have is water use in wildlife. Did some calculations just based on coefficients, and it is 10% of total water abstractions in Botswana in that year. A very large amount of water in that country. Tourism in Botswana, nature-based tourism is largely what it is the second largest industry, about $2,150 million US. It was the fastest growing industry. COVID has no doubt had an impact on that. but back in 2014, the tourism-related industries was growing faster than the rate of mining. It's a very important industry, largely based on nature, all based on which the wildlife all has to drink water. So we have the water provisioning service from the water assets. We then have the wildlife or the biodiversity assets drinking the water, and then the people going to look at that. And so there we have economic production and also human well-being. So we have a chain of services. We then have the case from Victoria in Australia, another one. We have a very large city dependent on water from some reservoirs. There is logging and other use of the area used to supply water. Done a time series of the water in and out of the reservoirs. We've then looked at the value of the company, state-owned enterprise, and its water, and what that's worth, how much it sells it. And in this, we get to what is water worth. And here, well, it must be worth what the water company sold it for. But then if we're going to start to do some valuation of some ecosystem services, we need to do some other things. And we used replacement cost method by Bram Edens, who has worked very closely with Lars over a long period of time. I'll skip over this. We get revenue from water supply from the company, and then we get the value of the water provisioning service. And what we can see is that, you know, it's about $100 million Australian per year, so 130 million US, all in current prices. We then get to the beneficiaries, and we find out that Melbourne Water, the industry value added, is about $380 million, and contributing to that is a water provisioning service of about $75 million. We can start to decompose this into various parts, and in Australia, because the price of water is constrained, the people operating the water supply businesses can make cases for changes to the management of land around them so that they can provide higher quality and more water. This is where some scenario modelling went in. So if you stopped supplying native timber and cutting the timber in the area, you would get increased water provisioning services over time. And in fact, the increase in the value of the water and the water supply industry far outweighs anything that the native timber production does. So we get this to the SEEA. What is it? It's a way of organising information so that ministries of finance, central training agencies can understand it. They are possible to produce, and it's an area that's rapidly evolving. So we can all learn from each other. Where can it be used? I mentioned this briefly, and I'm 30 seconds over time at the moment, but I'll just keep going with it's got about another minute, I think. Where it can be used, and accounting has traditionally been seen in this monitoring and review. But I think it also plays a key role in the issue of problem identification. It certainly did in Botswana, and it certainly has in Australia. It can help with framing a policy response, and it can certainly help with implementation. Where do you get the greatest value by changing activities, which is something we certainly saw here in Australia. This is the last slide before the questions. As I said, I've been very fortunate to work in a number of places over many years which support my work, and with a lot of people across the world. So thank you to everybody for your time and attention. And
at the moment, there is no questions in the chat box. So I think if someone wants to ask something, Michael probably is free to open his or her microphone and ask directly.
Well, maybe while other people think about their questions, I would have a question to Michael. And Michael, I thought your example of Botswana and both also of Melbourne were very interesting. For Botswana, I was wondering if wildlife is consuming 10% of the water, how is that perceived by farmers and the local government? Would they not say, oh, that's actually quite a lot? And in that context, I was also wondering if some of the water is not recycled back to the ecosystem somehow of the water that's being consumed by the animals. Have you had the discussion? Have you been able to put that in perspective?
So it was very interesting. So it was the Department of Water Resources in Botswana that was interested in doing that, and the two co-authors on that were from the Department of Water Resources, and it was the Wildlife Department that was interested in that because at the time they had a very large number of elephants, 220,000, which were coming south because of a drought to the north. And they were actually causing a lot of damage to agricultural land, and they also drink 225 litres of water a day. So it really was a management question of what to do with all these elephants, which were showing up, one in Botswana because of a drought further north, but two, they were protected, effectively protected in Botswana. And there was a discussion with the Department of Wildlife about what that meant and how it could work, and then how they could then work with farmers. On the issue of, and in that it was decided, well, they really didn't have much they could do, that no one was going to chase the elephants back out of Botswana, but it helped make the case for why they should keep them because it was such a big part of the income to Botswana, which I think crystallized part of that. It then also made the case that if you're going to use water in Botswana, it was much better being used for the wildlife than it was for some of the irrigation schemes which were being planned and possibly have gone ahead, although I don't know about that. But what was the alternative use? Accounting for the return flows in water has always been an interesting question. Yes, how we do it in the case, if elephants are drinking 225 litres going in, I'm assuming there's at least part of that coming out. So yeah, that would be accounted. It would certainly be of a different water quality. So we didn't do that, but return flows are always an issue, and how do we account for them in any sort of water accounting has often been that. But no, that wasn't considered explicitly in that study. Okay, so.
Okay, may I intervene for a while? Thank you, Michael. First, that you are so welcome to join in our seminar and of your nice, very interesting presentation. You mentioned that in ecosystem services in SEEA are initially based on sizes classification, but then in the last version of now SEEA, there is a reference list which is different from what we know from sizes. So can you do you have some more insights about this and how this would affect the work on accounting?
Yeah, the issue of the classification of ecosystem services has gone around in circles for a long time. And the last version, I mean, CICES kept evolving over time, and I actually liked the version, I think it was CICES 3.1. I think we're up to 5.2 now. Lars might know this better than I do. It really is an issue how to classify them, and in the academic literature it's quite different from the practitioners' literature. I don't have the answer, except I think we need to keep an open mind, and I think some of the key services are starting to emerge. Certainly the water provisioning one is there, the water filtration one. It's how some of these things line up. So I don't have a definitive answer. I'm sorry, Stoyan. It's here. I would defer to Lars on this one, how he thought the classification was going in general. But certainly from water, yeah, there are a lot of them, and just trying to sort through which ones and what are their definitions can be difficult. So, but Lars, did you want to comment?
Well, I would have preferred to comment on any other question than this one. Because It's really hard, right, to come up with a classification of ecosystem services that is fit for all purposes. It's really hard. And at the moment, of course, in the SEEA ecosystem accounting framework, there is a reference classification, right? So it's kind of a basis for countries to look at, but I think still it is possible, right, and sometimes appropriate to adjust also the definitions in the existing classifications to the context of the country. Right, so I think we're not there yet that we have a standardized classification of ecosystem services, and one of the more trickier ones are the hydrological ones. Still, I think we're making progress over time, right? That is also for sure the case. So there's discussion papers that were produced in the context of the SEEA revision by several authors, and those already provide some good insights. And I think the description in the SEEA ecosystem accounting framework now is getting close to something which is really workable, I think.
Okay, I think there is one question in the chat from, I can't say from who, to Michael. I saw price demand supply valuation diagram, but it's more like the illustration. Actually, we have the price as given, you don't need it for accounting. This is the question.
Okay, yeah. So I've got to just make sure I understand. In this, there are two ways. One of the ways is you can decompose the values from the exchange prices you see, which is one way of doing it, or the other one is to estimate it based on opportunity cost or some other type of exchange value. So in this, we do have the price of water, but what should the price of water be in Melbourne, considering it's price constrained, was one of the key issues. So it was what the company was allowed to charge rather than what it could be. So we have what's called, and this is virtually the case all around the world, is production cost pricing. Certainly the case in Australia, but also in Colombia, where the water accounts were used to help set prices. What would be the exchange value? I'm not quite sure. This is the supply demand. This is getting to another area, getting into the cost price value of water. And should water actually change price at different times depending on the demand, which is certainly a very key discussion here in Australia. And was one that was underway in Botswana as well. Essentially, in the dry seasons, should you be charging more for water because there is less water around and more demand? So often there is just a flat charge for water, maybe there's a service charge for delivery, and then a variable charge for volume. But then on top of that, you might be able to do other sort of pricing. So I'm not sure if I've understood the question, but I'm just saying a little bit about the water pricing, and it's been one of the key uses of accounts, and certainly 3 major water suppliers in Australia are looking to use, well, have used accounting to try to figure out that and to make some cases to the government agencies which set the price of water.
Thank you. I can see another 2 questions, but I think we don't really have time because we are out of schedule.
Geez, the first one is quite interesting.
Yeah, it's okay, I will read. Would you consider the water consumption by elephants as intermediate ecosystem service for ecotourism if elephants part of ecotourism activity since it is protected species?
Yeah. An excellent question, and we actually address that in the paper, and we conclude that it probably is when the elephants are within a national park. But if they're outside of a national park, it's different. So it's where elephants are and when and how the land is managed for where they are. So the national parks are managed for essentially tourism as well as wildlife conservation. This gets back to the diagram I showed. It's possible to account for things in different ways. but having intermediate and final ecosystem services makes it a lot possible, and then linking it into the system of national accounts where you have the production of goods and services is another link as well. So in all of this, the papers, I understand the presentation will be made available. There are links to the papers which go into some of that in a bit more detail. There's also, I see the replacement costs. Yeah, that most of those questions are answered if you go to the papers, or if you can't find them, please send me an email. Or if you have any other questions, please send me an email.
Okay, thank you.
I will show you now part of the MAIA project, the work on MAIA project on modeling the water regulation in support of ecosystem accounting. So my focus will be on the application of models and modeling approaches into the water regulation accounting. So in brief, I will start with a short background, then the main work which is almost fulfilled until now is a literature review on the application of models for water regulation. I will tell you some more about this review and what our preliminary results show about the modeling and the water ecosystem accounting. And fourth, I will show how it applies to one particular service, flood control modeling, which models how and so on, and some key findings and the perspectives, because it's an ongoing research actually. So as I told you, this is part of MAIA project. The work which I show you is mainly from the work package 4, testing new approaches and methods for accounting, and at the moment we are actually setting up the basis for this testing. In this work package we have several tasks, and my focus is on the task, the first of these tasks actually, which is called the same as the title of my presentation, modeling of water regulation in support of ecosystem accounting. So I will start with the classification problem which we just discussed. There are several ways to define which are the water related or water regulation services. Recently we had also discussion how to distinguish between the water related, which are which is the broader term, and water regulation services, and that was also quite important to set up our review tasks, because it's not easy to distinguish between them, and also not easy to distinguish the application of the models in all of them. So that's and in this slide you can see different how the CISES version, this was the last version of CISES, how the some of the water regulation services are found there, and in the end they are the services which we included in our review. And on the left down side, the services which were just releases in the reference list. So during the our work, which we actually were forced to integrate also this new emerging classification. So when we characterize and assess water regulation ecosystem services, there are several challenges, and the most important are that they can be regarded as both final and intermediate services, as was mentioned before. They need various data which usually are not available to direct and indirect measurements. This is especially valid for regulation services, and it is also that data extensive and analytically complex task. So therefore, modeling approaches for water regulation are much needed. This is the essence why we focus on modeling issues. Some more about the review which we performed in this task of the MAIA project. The main objective was to provide an overview of the efforts in modeling water regulation ecosystem services into the current literature and to establish the background to the how we can integrate these models into national capital accounting framework. And the specific objectives were to identify those models, to identify water regulation services which can be assessed by these models, and to define the main characteristics of these models which can be related to accounting, to specific accounting works. So we prepared a template which has two parts. The main part which is oriented to the main characteristics of the papers regarding to services, accounting, models, and specific modeling part which is designed to extract the specifics about the models, why it was necessary to distinguish into this way. First of all, for practical reason, because in the first part we have single row for single paper, but when we have two or more models applied in a paper, then it have to be organized in more structured way. That's why in the second part, in the modeling part actually, each row corresponds to particular model, and one of the main perspectives from this result is to link it with the MAIA Explorer, which was presented already several times in the previous webinars. And if we somehow manage to develop a catalog of models and research which can be linked with this MAIA Explorer and develop it into integrated tool between MAIA and toward not only mapping and assessment, but also accounting purposes. So some information about the review. We identified 148 papers published in 62 journals, quite different, quite variety of journals. You can see the highest number in science of total environment, and then you can see a lot of them. And the initial review, we examined that there are 139 different models and modeling approaches. So most papers were focused on single models, but there are also some papers that which present research with 2, 3, 4, and even 5 models. So the models integration, which is one of the actual topics in the ecosystem services research recently, here can be presented in its realities. In this map, you can see also the geographical scope of this research, with more research in Europe, North America, China is also well represented, Australia, less in South America and Africa, but also quite well represented worldwide. So the main challenges during this to fulfill this task were how to distinguish between the real models and modeling approaches and other methods defined as models, because in some papers, in some research, the modeling, the approaches which were applied were not specifically models, or a little bit different from the classical modeling understanding. And the question was, can we keep, or do we need to keep them in the review to be included in the future catalog, or should we remove them? So the second challenge was the great variety of models and modeling approaches, and the need to somehow systemize or classify them in order to make this review. So we developed this classification. First, to mention that we tried to find appropriate classification, but we didn't. So we decided to develop our own classification, including these 8 categories. I will not go in details about most of them, but the first 2 are classical models, hydrologic and hydraulic. The third is integrated modeling frameworks, which are so fast developing in the recent years in ecosystem services research, such as INVEST, ARIES, and so on. Then the integrated and then water-based models, which are typical methods which better fit the classical model understanding, but do not fit the above category. So they are not precisely hydrological models. Then we have GIS tools. In some research, they are used directly. GIS tools, water modeling approaches, conceptual or expert-based, and other models and modeling approaches which are not specifically water models, but they are used in combination with hydrological or other water-based models to assess particular service or management practice. So in this case, we decided to keep them also because they are used in combination to assess particular services. And some examples, some results. These results are already organized in a paper which was recently submitted, and we are now expecting for a review. So these 8 model categories, you see the most research are based on hydrological modeling, and 31 hydrological models were found in this research. But when we go to the specific hydrological models, we see that one of them, SWOT, is used in more than half, actually 55 from 99 models, which is quite big, which means that SWOT is by no means the most popular hydrological model used in the ecosystem services research from integrated modeling frameworks. The other most important part of the models and modeling approaches. We have similar situation with INVEST presented as the most used tool with 32 from 42 papers. So then we try to distinguish between the ecosystem assessment application and potential to use them in ecosystem services accounting. I am run out of time, so I can now go in details with in this parts, but just to show you, this is probably at the moment one of the most interesting results, how the application of these models is distributed between different ecosystem services. First, between the ecosystem services based on sizes classification, the upper bar, and between the services according to the SEEA reference list. And you can see that for each service, there are specific models which are more or less applied. I cannot go into details also in this, but and the other important point is that the left side of the figure shows the results from the whole group of papers. The left-hand side is only for the papers which are related to ecosystem services accounting. And you can also see some differences between them in both sizes and SEEA reference list classes. So I have an idea to give you some more details about the flood control modeling and how the hydrological models can be applied in this case. This is a short extraction of the review, and again we have SWOT and INVEST as the most used models. Here we have two important factors which can be taken into account. First, we have particular differences between rivers and coastal flood regulation, especially from biophysical point of view. They are totally different models and approaches that can be applied. In our case, for the flood control accounting in Bulgaria, which we are focused mainly on river flood regulation. Mitigation and prevention functions should be taken into account because there are different functions, and also different kinds of models and approaches can be applied for them. We have particular achievements in utilizing these hydrological models in ecosystem services assessment. Recently, the GRC proposed this structure to apply modeling for ecosystem service accounting, but it will be presented more in details in the next part by Sarah. So this is the general framework which we developed for the application of modeling in flood control accounting in Bulgaria. There are several steps which should be applied. We are just now at this type, applying hydrological modeling in test case studies, these places here, and how we can use the existing ecosystem services assessment results And the main task or the main challenge is how to delineate the service providing areas as precisely as possible. And this is in brief, because I am really run out of time now. The preliminary results which has been published this year for one of the case studies can be shown here. And the key findings from this research so far. First, the topic of the modeling of water-related ecosystem services is widely used in the scientific literature, which provides a good basis for both ecosystem assessment and accounting. The specific accounting studies are scarce, which is a gap in ecosystem services research that need to be filled. A variety of approaches is available. The hydrological models, SWOT, and the modeling tool INVEST are by far the most popular tools. The hydrological models are widely used, while the hydraulic models are far less popular. So this is another gap. And further development of the model database and its planet integration to Esmeralda MAIA Explorer will enable to expand the online methods database for mapping and assessing ecosystem services towards accounting. And the main research priorities for the near future was to analyze models in respect to their application requirements in specific application potentials, to analyze the spatial aspects of the models towards a clear distinguish between service and supply, between service supply and service use, and to develop guidelines for improved use of models in ecosystem accounting. And I also need to mention that this work was done by a team from MAIA, which includes these colleagues, which I would like also to thank them and to mention that they are deeply involved in this work. So thank you for your attention, and I'm open now for your questions.
Thanks to Jan for the interesting and detailed presentation. There is still no questions in the chat. I would like to ask you, you mentioned that you are going to have case studies. Have you selected the areas that you are going to apply this?
You mean case studies for flood control?
Yeah, because you show just a little bit for one case study.
Yes. These case studies are selected in quite practical reason. These are case studies which we already have flood regulation ecosystem services assessment. So the point is to use the existing data to integrate them for the accounting frameworks. Actually, the main task was at this point how to distinguish between service use and service flow, and also because in ecosystem services assessment we classified the capacity for flood control provision into 5 categories actually. And for accounting purposes, we need just to divide service providing areas. And the main task was how to, which classes to include into the accounting, into the service providing areas. For example, does low capacity should be included into the SPA or not, for example. So at the moment, we don't include also, only areas with higher than medium capacity. But whether is it the right approach, we can be still sure. So that's why I mentioned that this is the main challenge.
Okay, thank you. And if there is a relation, I suppose there is, but between the literature review that you have been made and the case studies that we are going to apply in your research. You said that INVEST and SWOT are the most used models in within the papers that you
Yes, they are. They are actually the results from literature review. This part, which is about the flood regulation services, they are directly involved in this scheme.
Okay. There is a question from Monica Supekova regarding ecosystem services served by floodplains, etc. In the case of flood protection and fighting with drought impacts, we will try to connect ecosystem services with so-called NWRM measures, or maybe to build up on the benefits identified in the project NWRM EU.
Yeah, good question. Thank you. So in the flood protection and you mean flood protection from the floodplains? Yes. From the modeling point of view, as I mentioned, there is different approaches. For example, in the when we apply modeling for at watershed scale, this is mainly about the services, the ecosystems, for example, mainly for forest ecosystems, for example. But for the floodplains, it's a quite different case. And in general, floodplains, in floodplains, the riparian vegetation and wetlands play the most important role. But what is the real amount of water that can they can collect it, that they can extract during particular event? It's a matter of actually of hydraulic modeling, and but I think this is the less developed part of the modeling so far. I don't know if I managed to properly answer your question. But as we are almost at the time for coffee break.
Yes, we are. So, okay, so there is no questions. We can go for our coffee break, and we will meet again in how many? 10 minutes.
Yeah.
Yeah, see you soon.
10:15.
Okay, well, my name is Sara Vallecillo, and as Stoyan mentioned, I work at the Joint Research Center. I'm going to present the case study on the accounting for flood control by ecosystems at EU level. This part, this work I'm going to present is part of the KIPICA project that some of you may know already about this project. Okay, this is the outline of my presentation. I will start with a brief introduction on ecosystem service accounts in Inca, how we develop them. Then I will focus on the mapping of flood control, mapping different components of ecosystem services, potential, demand, use, and unmet demand that I will explain in more detail later on about these different components. I will explain also the monetary evaluation applied for the compilation of the accounts. I will show as well the accounting tables in both in biophysical and monetary terms at the European level, but we have them available also at country level. And I will finalize also showing some key findings of the study we have done, and also some of the tools that will become available in the future to make more easily updates on flood control accounts within the STMAP toolbox. Okay, let's start then with the introduction of ecosystem service accounts. Well, as I mentioned before, this work I'm presenting is part of the Keeping Up project. This is a project that was carried out between 2015 and 2015. This is the cover page of the final report that will be released in the coming days. This project is part of the European this project has been developed by the European Commission, different services, and coordinated by Eurostat, together also with the European Environment Agency. This final report, presents the summary results for the accounts on ecosystem extent, on ecosystem condition, and ecosystem services at EU level, the European Union level. And here in this presentation, I'm going to focus on the ecosystem service accounts for flood control, as you know. But first of all, I wanted to explain a little bit how the Joint Research Center is developing the accounts for ecosystem services. First of all, we start making use of official statistics whenever they are available. Unfortunately, this is not always the case for ecosystem services, as you may know. The assessment of ecosystem services is still very challenging, and for that we need to develop spatially explicit models. We need to map first ecosystem services. They have a very strong spatial component, and then once we model them, we can quantify how much they are being used. And then we can translate the amount of service use, which is needed for accounting. We can translate it in monetary terms, and then we are ready to fill in the accounting tables. And as I mentioned before, accounting tables, the supply and use tables are filled in biophysical and monetary terms. I will show you later on the results at EU level. Well, for the biophysical models, I wanted to explain first, the Joint Research Center is mainly making use, using as the basis for the developing of the biophysical models, the MAIA framework. MAIA stands for Mapping and Assessment of Ecosystem and the Services. I guess you are familiar with that. It's the European Commission initiative to promote the mapping and assessment of ecosystem services in countries of the European Union. And according to this framework, we can map and assess different components of ecosystem services. We can map on one hand the ecosystem service potential. This is the amount and what ecosystems can offer in terms of services, how much recreation can offer, how much flood control, how much pollination. We can map, on the other hand, the ecosystem service demand. This is part of the socioeconomic system, and as ecosystem service demand, we consider what and where society and economy need from ecosystems. Based on the spatial relationship between these two elements of ecosystem service, the ecosystem service potential and the ecosystem service demand, we can then quantify and assess the ecosystem service use, which is the amount of the ecosystem service that is effectively provided from ecosystem to society. It is important that for accounting, we are mainly focused on this flow of services where there is a transaction from ecosystems to socioeconomic systems, because this is exactly what is needed to fill in the supply and use tables, and not other elements of ecosystem service as the potential. And because we are making use of these spatial models, we are able also to map other component of ecosystem services, what we call this accounting framework, the unmet demand. However, this concept is not completely new, because this is also known in the literature of ecosystem service as ecosystem service deficit. And this unmet demand is the needs from the needs of the socioeconomic systems that are not fully satisfied by ecosystems. I will explain later on how this can be mapped for flood control. Well, after this introduction, then I can explain you how we model flood control and these different components. So we adopted this framework I have explained before with all these components, and we adopted it to flood control. Well, Stoyan showed already this scheme because I think it's very graphical and helps to understand how this service was modeled. So as you can see here, we have mapped the flood control potential as a function of the runoff retention by ecosystems. We have applied for that the curve number method, assigning different coefficients of runoff retention depending on land cover type, soil texture, slope, but also imperviousness, the level of soil sealing. And this is important because this is considered as included this as indicator of condition of ecosystems, and it helps to establish this linkage between ecosystem condition and ecosystem services. On the other hand, we have mapped, well, first of all, we use one we have mapped the flood control potential. We are able to delineate the service providing areas. And Stoyan also mentioned this is a bit challenging because here, as he did, we are only focused on areas that provide high flood control retention. So we don't account for those areas that are not so good, but they still can do something. So we focus only on the good, medium and good areas for flood control protection. Then on the demand side, we have mapped the economic assets in floodplains, focusing on built-up areas, urban areas, and agricultural areas in floodplains for a return period of 500 years. These flooding areas have been modeled with least flood, but we are mainly making use of publicly available data, which was the aim of our model approach, to make it more accessible to different stakeholders. And then based on this spatial relationship between the service providing areas and the service demanding areas, we can quantify the actual flow. To do that, I wanted to explain a little bit. This ecosystem service is a directional slope-dependent ecosystem service. So the service to be generated, we need service providing areas to be located upstream from the demand areas. This is what I have tried to represent in this scheme. So we are able to quantify the actual flow based on the extent in biophysical terms, based on the extent of service benefiting areas. This is the amount of the demand, but that is protected by upstream ecosystems. So we can map the flood control potential and the flood control demand. As you can see, there's some complementarity in these figures. Areas with very low ecosystem potential show also on the other side show very high demand, and this is an issue. So we can also map and quantify the actual flow where the directional slope was considered, this slope-dependent interaction between service providing areas and service demanding areas. And we have also quantified the unmet demand, which ultimately is the difference between the demand and the use. Areas that would need more ecosystems to control floods. Then once we have quantified the monetary valuation, we can, once we have quantified the actual flow in monetary terms, we can proceed with the monetary valuation. For that, we have applied as a valuation technique the avoided damage cost. Using the damage cost functions at country level that are being used in the risk management unit here at DRC. We have collaborated with this unit to do this study. This damage cost function at country level give us the damage caused by floods for different water depths, from 0 to 6 meters water depth, and for different types of assets, economic assets, buildings, commerce, industry, roads, and agriculture. And based on these damage cost functions, we have calculated the avoided damage cost by multiplying the damage by the actual flow. I will explain you a bit more in detail because it may sound a bit strange, but for instance, if we have an area with buildings, and we have a water depth in a flood of 2 meters, then the damage would be 371 euros per square meter. In this area, if we have an actual flow of 1, it means that the full area upstream from this location, from this building, is covered by service providing areas. Then the avoided damage would be equal to the total damage. So here the effectiveness of the ecosystem is the highest. It is avoiding the total damage. While we have an actual flow of, for instance, 0.2, only 20% of the upstream area from this building is covered by service providing areas, then the avoided damage would be only 20% of this amount. And based on this approach, we can map, yes, here, we can map the value of flood control by ecosystem, and this is at catchment level. At EU level, the value of flood control by ecosystem has been estimated at 16 billion, around 16 billion euro. But it's important to highlight that more than 90% of this amount is due to the protection of artificial areas with buildings and services. While only a small percentage is due to the protection of agricultural areas. And actually, we can see in the map that the areas with the highest value correspond to areas with a lot of built-up areas in floodplains. So now that we have the actual flow quantified in biophysical terms and in monetary terms, we are ready to fill in the accounting tables. In green, you can see the accounting table in biophysical terms. We did this assessment for 2 years, I forgot to mention it before, for 2006 and 2012, but it was enough to assess some changes, which is one of the main purposes of accounting, to track changes over time. And here down, you can see in purple the monetary value. This is the supply table that shows us the contribution of ecosystems to the provision of flood control. And we can see that both in biophysical terms and in monetary terms, forests are the main ecosystem type providing this service, which is what could be expected. About 70% of this total flow of service provided is delivered by forest. And the value of forest at EU level, this is the EU average. Of course, it depends on the location, but the EU average has been estimated in 7,000 euros per square kilometer of forest. Then about the use table that shows the uses of flood control by ecosystems. Here we can see some distinctions between the biophysical table and the monetary one. Well, if we look only at the biophysical flows, we can see that 88% is used by agriculture. You can see that this amount is the largest. But when looking at in monetary terms, we can see that households are the main users of these ecosystem services, because 72% of the actual flow is used by households. And this is mainly used because of the difference of the value of the service. In agricultural areas, the mean value of the service is about 6,500 euros per square kilometer, while in built-up areas, this value is about 823,000 euros per square kilometer. So there's a big difference because of the difference in the prices of the avoided damage. And then I will show some key findings, some important results that came up with this study. When assessing changes over time, we found some bad news. We found that the value of flood control has increased by 1.14% between 2006 and 2012. This is the at EU value. Initially, we could think this is a good sign because the value of ecosystem service is increasing, but actually because we have made use of spatially explicit models, we are able to identify who are the drivers of the changes in the value of the service. And actually, this is a bad news because the increase in the value is mainly due to the increase of users, because there is in this period between 2006 and 2012, there is a urban sprawl in floodplains, which is definitely not a good sign. And actually, we found that the performance of ecosystems is decreasing. So actually, it's not telling anything good about the natural capital. Moreover, we found that about 67% of the demand is not protected by ecosystems. There is a huge gap or ecosystem deficit for both agricultural areas, but especially for artificial areas, for urban areas. But let's try to find the good news here as well. And we found, well, we thought that the unmet demand we are able to map proves as a useful tool to support flood risk management plans, because it can help to prioritize areas that need ecosystem restoration to really enhance the value of the service and identify key areas. Actually, we did a kind of validation, but of course, at country level is a bit coarse, but it's still interesting to mention that we made a validation of our results with data taken from the International Database of Disasters, MDAT, where we use the flood frequency per year at country level, and then we compare it with the share of built-up areas in floodplains with ecosystem deficit. This would be the unmet demand in built-up areas. And we found a positive correlation, quite significant. So if we decrease the share of the unmet demand in built-up areas, we are able to also reduce the flood frequency and the damage. So I think this provides a good application of the approach we propose. I would like also to highlight, mention here the importance of the linkage to ecosystem condition. And because, as I mentioned before, we included soil sealing in our modeling approach, we are able to answer to what extent soil sealing reduced the extent of service providing areas at European level. And actually, we did this analysis and we found out that about 30% of the decreases in service providing areas between 2006 and 2012 at EU level are due to the soil sealing, and which is quite a lot. And actually, in some countries, the importance of soil sealing in reducing the extent of service providing areas, so the ecosystem performance to control floods, in some countries is really large, like Slovenia, Poland, and Sweden, because of these changes in service in soil sealing. And yeah, and I would like to finish also showing the INCA website has been recently made public, where we are publishing all the ecosystem service. We have a map tool showing all the maps we have developed at EU level. We show the results of ecosystem service extent, and in the future we will also include condition. We have made available all the accounting tables at EU level, but also country level. And we are currently working on the development of a QGIS plugin to account for ecosystem services within the STMAP toolbox, and flood control is one of the services we are currently developing for. And I think this would be, I mean, really important to make it more accessible for more users and also make more operational the flood control accounts in a way. Okay, and this is everything from my side. Thank you.
Thank you, Sara. There are two questions for you. Yeah, the first one is from Monica. At which scale the calculation for EU countries was done, and which data were used to identify ecosystems in EU countries? Current land use or some satellite data?
We have made use of current land cover. This is, I mean, the basis of all the models we develop, also because the ecosystem extent accounts has been done based on current land cover. But actually, the data on imperviousness are coming from Copernicus. It's a Copernicus product derived from remote sensing. So we make use of both.
Okay, thank you. And in addition, I would like to ask you, yeah, it's related with the spatial dimensions. I saw that there are some strokes for Croatia and for the east part of Bulgaria. Why it's like this? They were didn't include it in this study, or?
If there are holes, it's because some data were not there, and perhaps this this is mainly driven by the delineation of the flooding areas. So yeah, maybe there were no data for the modeling in least flood to cover these countries. I don't know the reasons because I was not involved in this least flood run, but yeah, because data were not available there. Yeah.
Okay, thank you. Okay, next to the next question from Simon. How is the avoided damage cost calculated for all of the EU? How close does it related to the exchange value concept? For instance, compared to estimation the flood control values using housing prices in different areas.
Actually, well, sorry for that. I'm not the expert in the monetary valuation, but what I tell you, it's that, well, working at European level is very challenging, first of all, because of the data limitation, and housing prices is something that definitely is not available at EU level, and especially, yeah, in a especially explicit way. So for us, it was not an alternative.
Okay, another question from Benjamin Burkhardt. Aren't the assumptions for the SDAs quite hypothetical? Some areas may never or very rarely get into a real risk for flood. Flood risk is very complex and it's changing based on regional weather, climate patterns, etc. Some areas in your demand map, e.g. in Northern Europe, are not very much used by people, but still quite large demand areas are identified. This is, of course, also influencing the subsequent calculation showing in your presentation.
Well, I don't agree with that. Sorry, but because I don't think it's so hypothetical. So the flooding areas are there. Maybe the return period is not the most appropriate because we cover the maximum return period available at EU level, which is 500 years. It is quite long, and we have found, for instance, some people in the literature are covering only 100 years, for instance. But this is, yeah, we just wanted to cover a bit the maximum value we could get. Even when I think our method is a bit underestimated the value of the ecosystem service. And these are the flooding areas that have been modeled. Of course, everything is based on model, and these flooding areas would need to be updated if climate change is I mean, in the future, when to integrate climate change and land use changes as well, because definitely it's an important driver. But so far, I think these flooding areas are reasonable.
Okay, thanks. And the next question, excellent presentation. How do you take account into the lost ecosystem services lost due to build-up of dikes? Is in the countries with more natural rivers ecosystem deficit bigger?
Wow, good question. Let me read it again.
Is in the countries with more natural river ecosystem deficit bigger? This is the question.
Actually, well, we made an attempt to include dikes as well in the modeling, but it was, I mean, in the end, we came up to the conclusion that even when there are artificial measures in place for flood control prevention, still the ecosystems need to be there. And actually, in the end, we didn't include this artificial defense measure because artificial defense measure has been designed with a given landscape setting. So if we decrease the amount of ecosystems retaining runoff there, then the artificial defense measures wouldn't be so efficient anymore. So in the end, it's something in our modeling we don't make this distinction in the end. So yeah, the answer would be no. More natural rivers have a larger ecosystem deficit. It depends what is upstream, maybe, basically.
Okay, thank you. And I think there are no other questions, and we're just in time for the next presentation, which is...
But thank you very much for the invitation to participate. As was mentioned, Neville sends his apologies. So my name is Terry Hills. I work in the Department of Agriculture, Water and Environment in partnership with in his organisation, the Murray-Darling Basin Authority. So my department is a poll agency. We're not a National Statistical Office. We do work very closely with the National Statistical Office. In my presentation, I just wanted to talk through our journey on ecosystem with a strong water focus, and really looking at the question of how ecosystem accounts may be able to develop that are most impactful for decision makers. For the case study that we're looking at, I won't be able to talk through the results yet because they haven't been released in August, but I really wanted to highlight some of the aspects of the work that might be of interest to this particular group. As Michael mentioned, environmental economic accounting is a team effort, and we've got to join forces, share lessons wherever we can. So maybe the next slide. So fundamental to our approach has been strategy for economic accounts that we released in April 2018. And this has been for a number of reasons. Firstly, there was an agreed adoption of the UN SEEA as a part of this work. In Australia, we have 3 tiers of government. So we have the national government, the state and territory government, at the third level, the local government. So under this strategy, the national and the state and territory governments agreed to implement the UN SEEA. They also agreed to develop a core set of operational accounts with an initial priority on land accounts and waste accounts. The land accounts will be released tomorrow, probably in the middle of the night in Europe, but if you're having trouble sleeping, maybe check that out. When we were consulting with potential users on accounts and what they might be to be used for, it became very clear that stakeholders were interested in local decision making, and it sounded like really what they were interested in was the sorts of information that a system account could provide. This idea that such ecosystem accounts need to be ecologically meaningful, describe how ecosystems behave in Australia was a big priority, and a particular focus on how what is the relationship between particular ecosystem attributes and services in sort of dynamic ecosystem environment. So we decided to do a study on ecosystem accounting at a local scale site, and really what we were looking for was lots of policy relevance. We wanted a lot of ecological complexity. We wanted a strong partner, and we wanted contribute from a range of stakeholders. Next slide, please. So I just wanted to give a bit of an overview about the area in which we've been working, the Murray-Darling Basin, which met all the criteria that I just mentioned. As you can see from this slide, there's a lot of uses. So this is the basin itself is sort of 14% of the land area of Australia. It's I think it's the 20th largest river basin in the world. But as you can see, there's a lot of competing uses here. We have tourism industry. We have a lot of agriculture. We have a lot of recreation. We have a lot of fishing. There are the traditional owners of the land that are very interested in how the lands are managed, and we have a lot of environmental values. seemed like a perfect site to focus our attentions. Next slide, please. So I briefly wanted to introduce the concept of environmental watering because it may not be familiar to everyone. So essentially, water use in the Murray-Darling Basin, the way in which it's extracted and used is licensed. And as a part of that, since the early 2000s, around 25% of the water that was previously extracted has been purchased from irrigators and used for environmental watering. So return to the environment to improve the health of our rivers, plains, wetlands, and floodplains. So what we wanted to be able to do was understand the ecological response through both the natural flooding events, sort of artificial environmental watering events. And as time went by, there was a greater interest in understanding the economic benefits that were delivered through water, through the ecosystems. So, and it seemed as though ecosystem accounting was an ideal tool to be able to track this. Next slide, please. So the site that we chose with Murray-Darling Basin, we wanted to work at a scale in the first instance, was just over 50,000 hectares on the border between two states, New South Wales and Victoria. Why it was interesting and compelling was that one side of the southern side had received environmental watering, whereas the top side, the Coonderock Paracuta State Forests, they hadn't received environmental watering. It became sort of a natural experiment. So we've got an experiment and control site to be able to explore. We worked very closely with a range of local stakeholders as a part of this, understand what their needs were as part of this work, which leads me to the next slide. We spent quite a few months early on in the project discussing how we could build an account that was going to be most useful. And this is the list of the potential applications that through those discussions. This idea of social license for water reform was really focused on a bit of skepticism about whether or not people are actually receiving any benefit for environmental water that is being delivered. How are we getting value for money as a community? And really as a part of that, the core challenge was how do we disentangle the impact of environmental watering from natural variation. As I mentioned, we started on a small scale, but we were interested, based on the experience, what could be replicated and scaled up for the entire basin and eventually across Australia. So in terms of particular uses, supporting decisions on where and when environmental watering should take place to get the maximum, the optimal balance of social, environmental and economic outcomes. And the basin plan is the main tool that is used to govern the management of water across the basin. So as part of the evaluation of the basin plan, could ecosystem accounting be used to assess the impact of the basin plan generally. Next slide, please. So yes, a team effort. Our partners in the Murray-Darling Basin Authority were interested in doing was applying the ecosystem accounting framework all the way through from characterization of ecosystem types, their extents, all the way through to service benefits and asset value. So in order to be able to do this, we brought together a range of stakeholders. Really what you've got here is the core range of developers. So CSIRO on the left-hand side, they really helped us with asset size and type and condition. And then we worked with some environmental economists from GHD and Marsden Jacobs to look at the services and benefits side. And the Institute for the Development of Environmental Economic Accounting really helps us pull it all together and turn it into an accounts. Next slide. So the aspect of this work that I wanted to focus most on was the way in which SEEA on what they've called AusEco models, which is a state and transition modelling framework. How could that be applied within the ecosystem accounting process to give us this ecologically meaningful account? So in a bit of detail about what that means. But at the highest level, the site was broken into the 5 ecosystem type, and as you can see, a picture tells 1,000 words there. And these ecosystem types are consistent with the IUCN global ecosystem topology that is required under the UNCA ecosystem accounts. But where SEEA extended that ecosystem typology to look at the ecosystem states that sit underneath that. Acknowledging that each of these 5 ecosystem types can look very differently from over time, and depending on what's happening within those systems. So being able to understand, and I'll go into this in a bit more detail in the next slide shortly, but based on the endogenous and exogenous drivers, looking at the reference state at ecosystem type, which is based entirely on endogenous drivers, but then looking at the different states which are affected by exogenous drivers. I think we can move on to the next. So one of the 5 ecosystem types that we just looked at in the previous slide was what we've called inland floodplain, eucalypt, woodlands and forests. And this sort of gives you an illustration of the different states we looked at within this ecosystem type. And again, as you can see, the level of service you'd be receiving from these different states would vary, and that's where we're interested. The arrows between the 4 states illustrate how difficult it is and how what it is to move between these different states. So just very quickly looking at the top left, the reference state. So that's the one where you have moderate to high density and open eucalypt forest, no massive stresses going on. Underneath that, you've got a system where there are cumulative stresses this, based on grazing, water stress. So you're starting to see some canopy decline, you're getting invasion by exotic pests, these sorts of things. The top right-hand ecosystem state is really driven by logging more than anything, and the halophytic state in the right-hand corner is driven by salinization. So you end up with losing the canopy. You get basically a shrubland. So again, this is all the same ecosystem types, but different states that are available in that ecosystem type. Slide, please. Moving to how we consider the monetary and supply and use, we really wanted to take advantage of the rich information we had at the different tiers of ecosystem information. So what do we have at the ecosystem type level? What ecosystem characteristics? What attributes information on that were relevant to the particular production functions for the system services of interest. Apologies, you're probably not able to read what the individual services are here, but we're really focused on, I'll just read quickly from the top, biomass for timber, biomass for firewood, floral resources, carbon sequestration, water circulation, ecosystem appreciation, and recreation services. They're the ones that we dealt with quantitatively. We considered some others in a qualitative sense, including cultural traditional owner values. And there was other services that we acknowledged were relevant for reasons of data, and in many cases we didn't see them as being particular material in terms of overall ecosystem services for the site. You know, for example, flooding is a particular issue with the site itself. So in connecting these elements of the system and making the best use of the attribute information that we have on the different ecosystems and their states, we wanted to look at the individual ecosystem services. The one I've highlighted here is the recreation service, which I thought was an interesting example because people are attracted, they visit, their reasons for visitation will vary greatly, and you know, we don't really have particular on you know, the level of interest or the responsiveness to changes of visitation to moving between particular ecosystem states. So we had to a different approach to that. I mean, the reasons that people go into recreate within the site will vary greatly. Some are more interested in fishing. There's some hunting that goes on, just like camping. So we wanted to capture that. That's where the line with the attributes that we gathered through Oz Eco Models framework was most difficult. So we had varying success in terms of making the best use of the next slide, please, Nicholas. So in terms of how we're going to be engaging with the stakeholders as a part of the work, a lot of different audiences have a lot of different needs. As I mentioned, the local stakeholders, they're interested in some really compelling information about the benefits that environmental auditing offer them. They'll be less interested in the sort of global level services, and the interested in how service estimates will resonate with their lived experience is the expression that. Of course, our partners at the Commonwealth and the state and territory level, they'll be interested in the technical reports. As with, I believe, the international community, in terms of what lessons we've been able to gather through this experience that can then inform not only our future efforts in Australia, but elsewhere. And of course, there will be, each of these reports is quite extensive, so we wanted to synthesize that down into some like summaries and summaries for decision makers, you know, sort of 20, 25 pages and 2 to 3 pages respectively to try and maximize the impact. And that's where I wanted to look. Thanks everyone for your attention. My contact details are on that last slide.
Thank you, Terry, for your presentation. If there are some questions. There are a lot of comments in the chat box, but they are related with the previous presentations. Okay.
Perhaps it's my accent.
No, actually, one question from Lars. Terry, can you confirm us when the detailed reports will become available and how we can access them?
It will be early August, and I can actually send out an email to this group if that's useful, or I can send it to Nicholas and he can distribute it if that's okay.
I'm sure that people have other questions as well, and they may need to think a bit about it. I also had to type very fast to come up with a question so quickly. But Terry, I would have one more question while people are thinking about it, and I just do it in this way, if you don't mind, and that is, you described ecosystem types, but those are natural ecosystems. when you're scaling up to the whole Murray-Darling Basin, are you also considering agricultural lands as ecosystem types, or how are you going to include agricultural areas?
Yes, that's a good question. Thanks, Lars. What we wanted to do early was with the early work was focus on protected areas essentially, and so the site, they're both the two sides of the site are Ramsar listed sites. So yes, as part of the next stage, and we were just talking with the our partners at the Murray-Darling Basin Authority earlier today about what we would do in the next stage, and yes, we want to move into more agricultural sites, and that will, the collision of this Aussie Eco Models framework and agricultural sites will be very interesting in terms of how we use an appropriate typology.
Right, thanks. Yeah, and I guess also for the hydrology, right? Because much of the irrigated water, of course, is used in agricultural lands, and that's where some of the bottlenecks are, I think, in terms of environmental management.
Absolutely.
Yeah. All right, thanks. Sorry, I see there's more questions from others, so I'll just withdraw. Thanks.
Okay, Michael Varden is asking, what valuation techniques did you use? Can you describe a little bit more?
Yeah, sure. I'm getting some feedback, but we didn't use a standard ecosystem service modeling package as a part of this work, but the consultants applied a range of different production functions for the different services that we talked through. For example, for carbon sequestration, they used a modified version of the national carbon accounting system, parameterized with some of the information that was available from the sort of state and expression level. But valuation techniques, again, that varied as well. For carbon, we use the exchange value associated with one of the domestic programs that we have here in Australia, emission reduction fund. But we also looked at the social cost of carbon as well as the part of this. So we're able to look at both the welfare and the exchange values. I can email you, Michael, with the rest of the results on the different valuations.
No, thank you very much, Terry. I didn't mean it. It's just good to know, and I thought people would be interested to know a little bit more about that, including me. But yes, I'll await August with anticipation.
Okay, there are two more questions. The first one is from Werner. I have more general question. Is there any country that has tried to use ecosystem services and/or natural capital accounting in the context of the European Water Framework? This is the first question. I'm trying to apply it for the European Marine Strategy Framework Directive. Here I have seen some attempts by other countries as well. Or does JRC have plans to do something with water ecological quality? I'm not sure, probably this question is for Sarah?
Yes.
I'm not sure.
Yes, we can leave it for the final discussion.
Okay, the second question is to Terry. Biodiversity supporting services are often not considered ecosystem services as much, but in a way, with the hydrological model, would miss the mark in an Ramsar area. Would be grateful on comments.
Yeah, absolutely. one area that we didn't cover in sufficient. Originally we wanted to look at both water accounts and ecosystem accounts together, but in the end we only decided to focus on the ecosystem accounts themselves, and we're just combining that with water data at the moment. But yeah, certainly in the future, and given that we are talking about the Murray-Darling Basin, and they do have a wealth of hydrological modelling, I was certainly interested in how that will be linking through to the other service estimates in the future.
Okay, and one question from Lars. Terry, it is recently becoming clearer how forests are important for maintaining rainfall patterns. Among others, this was shown for Queensland by McAlpin. Are you considering this ecosystem service?
We're not, but it is an interesting one. I mean, I think part of why we weren't considering that was that it's sort of an inland area, and forest may not be sufficient to change the rainfall regime. But certainly, as we start to think about how this work would be expanded and linked with climate resilience, I think what you've suggested is an ideal candidate for future work. There was also a question just up there on, am I out of time?
You can go.
Oh, sure. There was a question about how the ecosystem classes are mapped.
Oh, yeah. Yeah.
I mentioned that the national ecosystem accounts, the national land accounts are being released, and as a part of that, a land cover data set was prepared, looking at the time periods that we were looking at, sort of 30-metre resolution, using the land cover classification system from the Food and Agriculture Organisation. So the way in which the ecosystem classes have been mapped are at that using that level of resolution, and they haven't been mapped all the way through to ecosystem states, but for the main 5 ecosystem types, they have been mapped for the 2 time periods that we've been looking at that 30-metre resolution.
I think we can now move to the general discussion to synthesize the webinar and go back for the questions that have been not answered yet. Probably we can.
Yeah, I think from the beginning there are some questions related with the first presentation, the Michael's presentation, but I'm not sure which questions exactly.
I think we can start with this question concerning the EU perspective, if Sarah is able to address it.
Yeah, good to make this question, because actually water is something that is not covered by the INCAP project at all, and actually it's an important limitation of our results. In the short term, we don't have plans to start working on the European Water Framework Directive, but I think it would be great to integrate this framework directive with accounting and make use of it, the reported data and so on for accounting purposes. We have a new colleague. She's working with us on the marine side, and in the medium long term, we are planning to start doing accounts also on marine ecosystems. So if you are interested, I can send you the contact of this person, or send me feel free to send me an email, and then I can put you in contact with this person. So I think it can be interesting to have an exchange of ideas.
Okay, and if we if we just stay for a few more time in at this EU perspective, I'm wondering whether your approach for flood control is also applicable at national level. I mean, the maps which you show at EU level and can be directly applied at national level, or we need to make, how to say, some kind of adjustment or more detailed modeling or so on. Did you think about this, or do you have some plans to develop it at this to this direction?
Yes, well, I didn't mention it, but the spatial resolution we are using for the modeling is 100 meters, so it's the resolution of Corinne, and we are doing all the analysis at this spatial resolution. I think this is reasonable enough to do the accounts and apply the modeling technique for at country level as well. It depends on the size of the country, of course, but for Luxembourg, maybe it's not enough. It depends, but yeah, but I guess that for even at regional level, I would say, and actually this is the idea of developing this QGIS plugin to make it accessible for different users and apply the method, because the method can be transferable at regional level as well. Of course, I mean, the model is flexible enough also to adjust it to the regional context. So if you have different input data or so on, then the better data quality you have, the better would be the output you get. But the approach is, yeah, can be applied at different contexts.
Okay, and one more specifically, the curve number method you used, as I know it, for the for land cover types, it uses particular indexes to be applied. Do you think that it is applicable for each, for, how to say, for example, forest? You use particular index for forest to apply curve number. Is it so? Is it applicable for all European forests, or we need to make some more precise calculations for different types of forest, different forest types?
If you have the data, I mean, the curve number you include and in using the modeling, it's a bit to be defined by the user. I mean, we made public the ones that we used, and it's based. Well, we try to make use also on data on ecosystem service potential for flood control and correlate this with the flood with the curve number. But it's flexible enough to fine tune depending on the data. If you have different types of forests where you think, because what is important, I think, in the curve number is to set the relative difference between land covers. For instance, we made also an application of this model to urban areas, and here we fine tune a little bit more the different types of urban areas we have. So it depends, yeah, on the purpose of the study and on the land cover on which you are interested. But I think it's, yeah, it's flexible enough, and if you have the ground basis to say this forest type has a higher curve number than another one.
Okay, thanks.
Maybe we could ask Terry what hydrological model was used in the in Australia in the Murray-Darling Basin. I didn't pick that up from the presentation.
There weren't any specific models that were applied as a part of the ecosystem accounting work. What we'd like to be able to do, I mean, we used existing hydrological information from the for the time periods that we're looking at, but in terms of the future flow of services and modelling that, we didn't actually do that. We just assumed constant flows in the future based on the historical flows, essentially.
Right.
Maybe, Terry, my understanding is the Murray-Darling Basin Commission uses SWOT. I could be wrong. In general, for their information.
Yeah, no, that sounds right. Thanks for saving me.
Yeah, I think SWOT is really applicable, right? If you have one large basin and you work with your hydrological response unit, so it's quite good. But I think in Europe we have the challenge, of course, there's so many different basins, and for some of these basins we don't have any hydrological data or not the amount that you need to calibrate at least a SWOT model. And then we really run into problems of what model we can use, because on the one hand, if using SWOT seems too data intensive and too complex, and on the other hand, you would like to perhaps have sufficient or real ecological detail in your model as well. So it's really quite hard to get that going at European scale. And of course, the JRC work is really a great methodology already. But there's still quite some assumptions maybe that at some point, they kind of can be discussed and see what refinements are possible in the future. But it's hard to see that clearly which are the key improvements. What do you think, Sarah? What would you say? Look, in order to improve the model at European scale, what would be your priorities?
To improve these models?
Yeah.
One of the limitations I think it has is the delineation of service providing areas, because for that we need to set a threshold, which is a bit arbitrary. It would be nice to account for the whole landscape, how it contributes, even when it has low capacity to retain runoff, but it's still contributing somehow. But this was, we should further investigate how this could be done. Another limitation is the delineation of the flooding areas, because actually we are assuming in this I think and actually we were discussing also with our colleagues in the disaster risk unit to simulate the flooding areas with the absence of ecosystems, how this would look like. So to run least flood and generate the flooding areas in the absence of an hypothetical scenario without any ecosystem at all retaining runoff. But first of all, this alternative, conceptually is, I think, a bit too, not very realistic in terms of scenarios building, because the lack of ecosystems is something I hope cannot be achieved and no point. And actually, we had also time constraints to implement this alternative modeling of flooding areas, because it would be nice to see how flooding areas would be enlarged and actually would reach a higher water depth in the absence of ecosystems. So these are the two main limitations I see. But I think actually I agree with you. Of course, it's based on many assumptions, and it's avoiding the use of hydrological models that are very demanding in terms of data and computation. So we try to do these alternative methods based on the ecosystem service perspective with this delineation of service providing areas and demanding areas. But it would be nice to compare somehow the results of this modeling with other more detailed and see if they are aligned. Of course, uncertainty models it's still very large, and I think we can only compare what we get with different models, and this will help to see and help to interpret better the results.
Okay, I see the question from Michael about the potential recommendation on which models should be used for water regulation. I hardly can make some recommendations now because these are just preliminary results. What can I share from my experience is that the application of, for example, hydrological modeling, hydrologic models is very much dependent on expertise because, as was mentioned, SWOT is quite specific and needs it's time consuming to apply hydrologic model in a particular area and apply it in, for example, at national scale or even continental scale is not realistic. That's why the curve number method, which was proposed by GRC, is quite good option. So some kind of combination of these, for example, application of specific hydrologic models in case studies where we can extract more parameters, for example, like soil infiltration, like surface runoff, and so on, and can calculate how these combinations of land cover, soil, and other parameters such as slope can be modeled in more details, and then extrapolate this to how to say types of watersheds. That is that is my idea behind this this conceptual scheme about flood regulation in Bulgaria. So it very much depends on expertise of the team and how particular model is developed. At this point, we can easily say that SWOT is by far the most useful. There is a large user community with this model. You can easy how to say use this forums that you can if you have a problem you can write and then easily find colleague who was working on this problem and can share with you. So that's why SWOT is very good option. Invest Now is going to become the same for specific ecosystem services modeling too, and so on. But all the others are, how to say, used by people who have experience on particular model, particular approach, and they try to adapt it for ecosystem services purposes. That's why there is so big, so great variety of approaches found in different publications. So that is my impression at the moment.
Okay, and there was a question from Joanna about the literature review that you have applied. Did you also examine as a site activity how water ecosystem services were assessed in monetary terms in these studies?
Yes, we did. I can now go into details now, but it will be published. So I hope the paper will be published soon, and then there will be, you will be able to see some of these results. And Sarah asked which percent of the papers you reviewed were also applied into accounting. Yes, I didn't pay much attention of this in the presentation. It was part of one of the slides. There were 148 papers. In 10 of these papers, we found that the accounting is part of its primary purposes. Then there were about 37 or 38 papers which have some relations to accounting. For example, they were mentioned in the discussion or something like this. So from these 148 papers, let's say 1/3 have some relation to accounting.
Thank you.
So we are almost into the frame of the schedule. It's 11:30. So probably some final comments or schedule.
I think we can
thank you,
close.
Stoyan. Oh, sorry.
Sorry, no, Michael, go ahead. You go ahead, please.
No, I was just going to thank Lars and Stoyan for the opportunity and just trying to pick up on a few things, but I think it's some of these classifications of the services and then of the ecosystems are things we really do need to think about because it is still not neat. But the other one is when we get to the accounting, there really is a cascade of services. And I think some of the accounting formats, we will really need to figure that out. What is an intermediate service? What is a final service? And then where it converts into a product. And I think that's one of the challenges going forward and where the central framework and the ecosystem accounting blends over. The other thing which struck me in the presentations was we had very much a presentation on the assets supplying services from Terry, whereas the other ones were focused far more on the ecosystem services themselves. But the services come from the assets, which I then think gets back to our classification. So we need a classification of assets, which is the ecosystems, and then a classification of the services. And the international classifications for both are not particularly good at a local level, it would be my assessment. But anyway, thank you. I just had a few thoughts. Valuation, sorry, is always the big question. So we can park that one because we will never get agreement. It's been disagreements for 50 years and we're not going to solve them very quickly.
But we're making progress, Michael. I think it's good to stay optimistic.
Yeah.
We are making progress, even on the valuation part, I would say.
Yeah.
I think it's time to close, Stoyan and Christina.
Yes.
Would it be okay? Because it has been 11:30. Some people are really, I'm really thankful to people from Australia and Philippines and Asia, especially, right, for staying up so late. But of course, everybody, thanks very much for joining. Many thanks to the speakers. It was really interesting. I must say, from a personal perspective, I really enjoyed the presentation from the River Basin Authority. Because it's an administrative unit which is really paying for development of accounts. I mean, I think that shows also the policy relevance of what we're all trying to do here. So that's great. So thanks everybody. Thanks to the speakers. Thanks everybody for listening in. And Christina and Stoyan, many thanks for moderating this webinar. I think we can close it. It has been very, very interesting, I would say. Thanks everybody. And take care, everybody. Right. Goodbye.
Goodbye. Thank you.
Bye-bye.
Thank you.